Thank you. Good morning to all hackers. Hope you had a good rest and are fit for the next 24 hours. So let's jump into it. So these are the data sets that we have available, and you're all assigned to a group. So we have the stroke rehab data, we have unresponsive wakefulness syndrome, also called UWS. We have the locked-in patients. We have a standard P300 speller. We have SSVEP data, and then we have two ECoG data sets. One time the ECoG hand pose data and one time ECoG video watching analysis. So myself, Sebastian, and also Johannes will be supporting you on Discord during the hackathon. So please, if you have any questions, just ask them there, and we will try to answer them. We will not join any external Zoom meetings or whatever you would do, because this would be unfair to other groups if we would leave Discord for a while to join any other discussions. It's not possible because there are so many groups. So just to communicate with us, please stay on Discord. Okay, for our first data set, this is the stroke rehab analysis. In the stroke rehab analysis, we have data recorded with our Recovery system that you may already know. If not, please check our internet pages for it. In the stroke rehab and the Recovery, we ask patients to do motor imagery, to imagine to move the left and right hand, and we provide in real-time feedback based on the classification of EEG. We provide FES stimulation and visual feedback. And in the data set, you will see 80 trials. One trial is one movement of left or right hand. 80 trials of left and right hand in one data set, and one trial looks like what you see here. It takes 8 seconds. At 0 seconds, you have an attention sound. At 2 seconds, you have the command either to move the left or right hand. At 3.5 seconds, the feedback phase starts, where the feedback is switched on or off. And then at 8 seconds, the trial ends and you receive a relax command auditorily. And then there's a short break and the next trial will start. You receive in the data of 3 subjects, P1, P2, and P3. And of each patient 2 sessions, a pre and a post session. Pre means before they received Recovery training, and post is a session after 25 sessions of Recovery training, where they should perform better. And in each session, you have 2 data sets, a training and a test data set. So you can use one to train a classifier and the second to test the classifier. And you see here 2 different kinds of accuracy values that we have achieved with 2 different methods of signal analysis, CSP plus LDA or PCA plus DVLDA. You will find those methods described in the papers attached to the data sets. This is the montage, the EEG montage on the head. We got 16 channels according to the International Extended 1020 system. You see the names here. And this is how the data looks like that you can download after the group formation. So you have these patients, P1, P2, P3, and 4 data sets per patient. You have a PDF that gives you, again, data set information describing how the structure is. Then you have the paper describing more about the signal analysis, and also this one. And yeah, this should be enough to give you a good idea what's going on. Next one is the P300 speller. So what's a P300 speller? I hope you know. If you don't know exactly, you could look in the internet. There are many sources to look for it, and you can also read, of course, here's a paper attached to see how it worked. But in very short, you have visual stimuli on a screen, and we are measuring the EEG after each visual stimulus, and there are certain target stimuli that will create a different shape in the EEG compared to the non-target stimuli. And this difference in the EEG you can measure and detect and classify, and that's what we're using to control a P300 speller. Also here you will receive, in this case, data of 5 subjects. They all used a row column flasher. So in the paper there's a single character speller and a row column flashing speller. We only provide here data of the row column speller. You will have the explanation what it means in the paper. And also, the accuracy values in the paper, and you could try to reach similar or even better accuracy values. Also, data looks like this. If you load one data set, you will have 3 variables: the sample rate, called fs. Then you have a variable called y. This is the EEG data in a matrix of size samples times channels. And then you have a third variable called trig. That's the trigger data. It goes to -1 for a non-target stimulus. So it's a short trigger going to -1 and go to +1 if it was a target stimulus. This is the montage you have here. You have 8 channels in this case. And this is how the datasets look like. MATLAB files, the montage, dataset overview, again a description of data, and then publications about how we did the signal processing. Next one is the steady state visual evoked potentials, SSVEP. SSVEP also uses visual stimulation, but constant flickering lights. They're flickering in a certain frequency, for example, 17 Hertz and 14 Hertz. And if the user just focuses on one of these flickering sources, you will find the stimulation frequency of this source has an increased power in the EEG. So you're watching at 17 Hertz, you will find a peak if you calculate the power of the EEG at 17 Hertz, or at 14 Hertz if you're watching the 14 Hertz. And this is used to classify on which source the user is focusing on. In the datasets, we recorded data where persons looked at 4 different flashing sources and stimulation frequencies of 9, 10, 12, and 15 Hertz. Sample rate 250 Hertz. And this is how the data looks like. In channel 1, you have the sample time, so that's just a constantly growing value. In the channels 2 to 9, you have the EEG channels. So again, you have 8 channels. In channel 10, you will find the trigger info, which means if the LED was on or off, the flickering one, and which one was flickering. And in channel 11, you have a classification output. So we also classified already those data, and you could try to challenge our classification results. You receive 2 data sets from 2 subjects. This is the montage, the EEG montage. So you have all positions here on the backside of the head. And this is how data looks like. You will find each data set this time in MATLAB format and also in the EDF format. So this and this, each time it's the same data, just converted to EDF if you prefer to use those EDF formats. But apart from that, you have subject 1 and subject 2 and training. And you have the description of data in this publication, also data description in the text file, and the class info tells you which LED was flashing at which time. and you have the montage. For the UWS data, we go back to a P300 speller, but this time it's a tactile P300. So you get tactile vibrators on the patient's left and right hand, and also on the left ankle. So we got what we call vibratactile 3-tactor stimulation paradigm. Again, the task is for the patient, for the user, to focus on one kind of stimulation, and then in the EEG, the shape will look different compared to the stimulations where I did not focus on. And your task in the signal processing is to find these differences. This is how the montage looks like. And you will receive data of 2 patients, each one 2 sessions, and 1 session of each patient, we reached a very low accuracy, below 5% classification accuracy. And in another session, we reached a very high accuracy, above 95%. So in each session, you again have 1 data set for training and 1 for testing. So these belong together, and so on. If you open 1 data set, you have again 3 variables: the sample rate, the variable called Y, which is the EEG data in the matrix, in the size samples times channels. And then you get the trigger data, where -1 is stimulus of a distractor, that's the one on the ankle. +1 is a non-target stimulus. This is one of the hands, but the system tells the patient on which of the hands he should focus, and this one is the target. So either left or right hand stimulus were the target, and these are marked as +2. And the other hand, which was non-target, gets in the trigger data +1. Yeah, explained also here again. So you have the +2, -1, and +1. Next one, ECoG and pose data. Here we have a 3-class paradigm where users are asked to perform gestures. And the gestures were make a fist, make the peace sign, and open the hands, open all fingers. And in between there was always a rest command. So the commands they received was always relax, and then do one of the 3 tasks in randomized order: relax, make a peace sign, relax, make a fist, and so on. And you will find 3 times for the 3 classes times 30 repetitions. So of each class you will find 30 trials to classify. This is how the data looks like. Of course, we have a higher sample rate in ECoG data, in a higher number of channels. So in channel 2 to 61, you find the ECoG data. Channel 1 is just the sample time. And channel 62 is the paradigm info, where it shows you which command was presented to the user. If channel 62 is at 0, it was the relax command. For 1, it was the fist movement, 2, the peace movement, and 3, open hand. And for channel 63 to 67, we have also data cloth information that shows you the movement or the position angle of each finger, from thumb to little finger. This is how the data looks like. You again will receive the data description PDF, a nice summary of how the structure of data is. Then of course the MATLAB data file and the publication showing you the signal processing we did on those data. And finally, there's the ECoG video watching. in this, we showed a video to a user. I think the video was recorded in the garden in Schiedelberg. You see the nice green grass here. And so a person was moving with a camera through the garden and going through different objects to show on the camera. So it started with a body and then a face, and then you had digits, era, kanji, line sketch, and an object. Also, we had here in the data this black mark where we place the LED sensor. I will explain this in the next slide what it means, but the LED sensor could sense when this rectangle went to white, and each time we showed a new object, one of those, it quickly went to white, so that we have in the EEG data the exact timing onset as soon as we switch to a new visualization. So in the EEG, you can find the timing. Now it switched to the new object to show. You will find, again, a publication explaining all the paradigms and the signal processing. And this is how data looks like. Sample rate of 1.2 kilohertz in the channels 2 to 161. You have the ECoG. And in 162, you have this photodiode feedback. This is what I just explained, the sensor that goes to 1 each time a new object was shown to the on the screen. And you have this channel in the EEG, so you can look exactly for these time events. And then you have the STIM code, which one was showed, and the group ID. And data is not yet referenced, so you could maybe reference your ECoG data. And that's it. Thank you for your attention. As said, we are in the Discord channels. And yeah, good luck, have fun.
Thank you very much, Rupi. A couple of questions. Victor wants to know, is the analysis of stroke rehabilitation mandatory to do in MATLAB, or can he also use Python?
Yeah, you can use whatever tool you like, of course. And also you can be creative. You don't need to do signal processing. I mean, if in a way, yes, but you don't need to challenge our classifications. Maybe if you have another idea what you want to do with the data, then that's totally fine. So just surprise us.
Basileus wants to know, is the metadata stored in the MAT file, or how do they get them, and do they need it at all?
Yeah, so most time or always you will have this 3 channels, 3 variables. When you open one MAT file, you get 3 variables. So the raw EEG is in the Y data, and then the metadata like trigger information is in what we call trick, and the sample rate, that's just one variable. That's quite easy. But everything you need to know, like timing, is stored in the MATLAB files.
Margit wants to know, for the motor imagery task, how long should be the resting period and how long should be the activation period to get a meaningful setup, and how many trials should be acquired? This is, I guess, not so much for the data sets, it's more for real-time experiments, but go ahead.
Yeah, so how many trials? I did some evaluation to see how many trials are necessary to have a nice classifier, and I think it starts at around 50 or 60 trials. You shouldn't go below that. And here in the data, we have 80 trials. We do a short pause in between the trials of 1 second. That's enough. If you do longer pauses, then just the whole session is getting too long and you're tiring your user, and you don't want to do that, of course. So it's always a trade-off to make it not too long and still acquire the most data of it.
How can you avoid mental fatigue during the experiment?
Good question. I mean, patients are often highly motivated, of course. They want to achieve a goal, so they're not easy to get tired. But for example, for our recoveries, we have games, and you will see them on Monday. And so these games have the same paradigm. You get the same motions to do, but it's a nicer way of presenting the tasks, and this serves to prevent that you get fatigue in the patients. So motivation is of course a key element always.
Yeah, fatigue normally occurs after doing something for like 10, 12, 14 hours for a very long time. But at Spring School, of course, we have the unique setup that this is so exciting that nobody gets fatigue. Sebastiano Marinelli, must be a Italian guy, wants to know if we have any questions regarding the datasets, which channel on Discord can be used for it.
The group channels, and we are reading them, and so just ask the questions there. We are going through all the channels.
Are you logged into Discord? Maybe you can maybe just show it how this is done.
So there are all these channels here. If you just post your questions there in this groups, we will check for it and try to answer it as quick as possible.
You can also tag people by just adding an @ before the name, and then they are prompted. So if you need help from Rupert, type in @Rupert Ortner, and he will receive a message, and then you can ask him directly. Same for Martin, Bernard, Johannes, and the other guys helping. Okay, I guess we have all the questions. Thank you very much, Rupi.